Hi everyone, welcome back. So we're just going to jump right into it. In the previous video, we figured out all of the rate laws for each of these mechanism steps that we're working on for question number 16. And we determined that this slow step is our rate determining step. And it's always going to be the slowest reaction for any of these types of problems. And we have the overall rate law for that equation. And what we noticed in the last video is that we have this intermediate concentration in our rate law. And remember that we never want to see any intermediates or products in our overall rate law. And so what we're going to do in this video is substitute in slowly each of these equations to get rid of E, and sort of as a spoiler, that's going to make a couple of the other intermediates and products appear in our rate law. So that's why we're going to use all of these equations to eventually get rid of our intermediates, which are E, F, and G, as well as our products, which are C and D. So we're just going to go ahead and get started with the substitutions. So we are going to start with, we're going to put our rate law right at the top here, because that's what everything else is going to go into. So that's the rate is equal to K5 times the concentration of A times the concentration of E. And now, and I'll highlight it here, E is one of our intermediates. So that's what we're looking to get rid of. So we're going to go back up to all of our steps and we're going to find an equation that has the concentration of E in it. And that's the one that we're going to use. We're going to solve for E and then we're going to put everything that E is equal to into our overall rate law. So this first equation here, elementary step number 1, has the concentration of E on one side of it. And it actually, E doesn't appear in any of these other steps except for the final rate law that we're working with. So this first equation here is the one that we're gonna start with first. So we're just gonna copy that down underneath our rate law. And so our first equation is K1 times the concentration of A squared times the concentration of F, and that's equal to the backwards reaction, K minus 1, times the concentration of C, times the concentration of E, times the concentration of G. And now what our goal is to solve for E. We want to get E equals something, and that something should include everything else in this equation because that's what we're going to plug in to our overall rate law here so that we can start to get rid of the intermediates that we have. So we're going to isolate E here. And to do that, we're going to divide everything that E is multiplied by so that we get rid of it on the right side. So we're going to divide by that rate constant K minus 1 times the concentration of C times the concentration of G. And now remember our algebra rules. Anything we do to one side of the equal sign, we have to do to the other. So we're also going to divide the left side of this reaction by the exact same thing. And so that is going to give us the concentration of E equal to, let's see, K1 times the concentration of A squared times the concentration of F divided by K minus 1 times the concentration of C times the concentration of G. So now we've isolated E on the left side here, and now everything that E is equal to, we're going to plug in for E in our overall rate law. So it is going to get a little bit messy, so just try and keep your work as organized as possible. Use as much scrap paper as you need to. Maybe number the steps or write a little bit of a description so that you can keep track of things in your head. So we have the overall rate is equal to K5 times the concentration of A, and then everything that E is equal to, so all of this. And so that would be K1 times A squared times F divided by K minus 1 times C times G. And now we want to combine things or simplify them as much as possible. So what we have is an A and an A squared. So we can combine those because everything in this equation is multiplied. So we can combine those to be A cubed. And then what I'm going to do is just move these rate constants just over a little bit so that they're next to the rate constant for the fifth equation. And we can move things around because if everything is multiplied in this equation, so it doesn't really matter the order that they appear. So we have our rate is equal to, and I'm going to just put all of the rate constants here. Everything's still multiplied, so this is totally okay to do. And then we have A to the third power because we have 1 from our original rate equation and 2 from our substituted equation. And then it's still times the concentration of F divided by the concentration of G and C. All right, so now that's our updated rate law. So now this is the equation that we're going to be plugging everything else into because we've updated it from this one that I had on the top here so that we could substitute the concentration of E, which is an intermediate. And then what you'll notice, while we did get rid of E, now we have a couple extra things that we don't want in our equation. We have F, which is another intermediate. We have G, which is another intermediate, and we have C, which is a product. So this might just be personal preference, but I like to take care of the intermediates of the reaction first and then take care of the products. I don't think it should matter which order you do them in, but that sort of works for how my brain thinks, so maybe it'll work for you too. So we're going to focus on just one of these intermediates here. We're going to focus on G, and this is totally arbitrary. We could do F first if we wanted to, but I'm choosing G for the sake of this problem. So we're going to go back up to our elementary steps here, and we've already used this first one to get rid of E. So now we have 3 options left. And we want to look at if our next intermediate G appears in any of these rate steps. And it does. It appears in elementary step number 4. And actually so does F here, as well as that product that we still have in the rate law. So this elementary step number 4 could be a really helpful substitution. It might help us cancel out more than one thing. So that's the elementary step that we're going to use. So I'm going to put that down here. And that's K4 times the concentration of B squared times the concentration of G. And that's equal to the backwards reaction, which is K minus 4 times C times D times F. And so we want to substitute in just for G. So that is what we're going to isolate here. So just like what we did when we were isolating the concentration of E, we want to isolate G on its own. So we're going to divide both sides by everything that G is multiplied by, because whatever we do to one side of the equation, we always want to do to the other. And so sort of a simplified way of doing that is just dividing the entire equation by that if you don't want to rewrite it on both sides. So both sides are going to be divided by K4 times B squared. So I'll just grab a new page here. So we have G is equal to, and then everything on the right, K minus 4 times C times D times F, and that's divided by K4 of the forward reaction times B squared. So now we've isolated G, so we're going to put that back into this updated rate law that we have. And so we have and I'm just going to actually copy it from here. There we go, and I'll get rid of this extra stuff. So we're still substituting in for G. So now we have our rate law is equal to everything that was already there, all of these rate constants, times the concentration of A cubed. We still have F. We still have it divided by C. And now the one thing that I want you to pay attention to is that G is on the bottom of the fraction here, which means we're going to be dividing our rate law equation by all of this that G is equal to. So when we're dividing by something with fractions, everything's going to be flipped. So whatever's on the bottom is going to turn into the top of the fraction, and everything that's on the top of the fraction will turn into the bottom. So we'll multiply by that reciprocal. So we have K4, and that's going to be B squared, and then divided by everything that used to be on the top. So K minus 4 times C times D times F. And so now we can start to cancel out things that are similar, if we can do that. And we can actually. F appears on the top and bottom of our fraction because everything here is multiplied. So we can actually, whoops, I did not mean to do that. So we can actually cancel out the concentration of F on both the top and bottom. Unfortunately, we can't do that with C because they're multiplied, so they're not going to cancel out. They'll multiply to each other, but that's okay because we were able to get rid of both G and F in this equation. So we were able to actually get rid of two intermediates at once, and that's why I did just the substitution for G, but it's totally okay if you didn't completely see that you wanted to do just one of the concentrations of intermediates at a time. These kinds of things just sort of take practice for you to sort of see the patterns of what you want to cross out and what you want to substitute first. So the best way to start recognizing those patterns is just to do a lot of these types of problems and get that practice in so that you start to see what's best to substitute first, where can I substitute things so that lots of different intermediates or products cancel out at the same time. And I promise you that will all come with practice doing these problems. So what we're going to do now is just simplify our updated rate law expression. We're going to pull all of the rate constants just over to the left side of this reaction, just to have everything in the same place so that we can see all of the concentrations that we're working with and what needs to be substituted next. So we have our rate is equal to K5 times K1 times K4 divided by K minus 1, which is multiplied by K minus 4. And then the remaining concentrations we have are A cubed, B squared, and now it's divided by C here and C here multiplied together to be C squared, and then we have multiplied by D. So this is our new updated rate law that we're going to substitute things into. So we can now check to see if we have intermediates or products in our reaction. We have A and B, which if you'll remember from our chemical equation, those are both of the reagents. So those are totally fine to leave there. But on the bottom, we have C times D. And C and D are both of our products. So we can find an equation that possibly has both C and D in it because we want to get rid of those in our overall rate law. So we're going to go back up to all of our rate laws. And we can check off this fourth step because we just used that to get rid of G and F. And then we're going to look to see if any of our reactions have both C and D in them, ideally multiplied together, so that we can cross off more than one product at the same time. And so this third elementary step here has both C and D multiplied by each other on the rate of the backwards equation. So we're going to use this third one here. So we're going to go back down to our rate law, and then we're going to copy that rate for the third reaction. So that was K3 times A squared is equal to the backwards reaction, which is K minus 3 times C times D. And now one sort of important thing that I want to point out is that on the bottom of the fraction of our rate law, we have C squared times D. So another way of writing that is C times D. And whenever we're doing these types of substitutions, we want to substitute for exactly what we're isolating in the individual rate laws. So here we're going to isolate C times D, and that's only part of the bottom of the fraction here. So when we plug this equation after isolating C and D, when we plug it into our rate law, we are going to be left with a C, but that's okay because we still have one more elementary step to work with. So hopefully that one can let us cross out this last C. But just make sure that you're keeping that in mind when you go through these types of problems. You're only substituting for what matches exactly, and that's just part of the bottom of this fraction. So if we're isolating C over D in this elementary step, the only thing that we actually have to do is divide both sides by K minus 3. And so that means that C times D is equal to K3 times A squared divided by K minus 3. And now everything on the right side of this equation is going to be plugged in, here for C times D. And remember, just like our other substitution step, it's on the bottom of the fraction. So everything that's equal to C times D is going to be flipped, because we're going to be dividing by a fraction, which means that we're multiplying by the reciprocal or the opposite of this fraction. So if we want to write out the substitution now, we have the rate is equal to K5 times K1 times K4 divided by K minus 1, K minus 4, and that's equal to multiplied by A cubed B squared divided by C, because that's what's remaining, and then we're going to multiply by the reciprocal of what C and D is equal to, because it's on the bottom of the fraction. So the top becomes the bottom, so K3 times A squared, and then the bottom becomes the top, so that's K minus 3 up there. So we can do the exact same thing we did before, see if we can cancel out anything. And we see that we have A cubed on the top and A squared on the bottom. And so that is the same thing as writing A times A times A, so that's A cubed on the top, and dividing it by A times A on the bottom, which is equal to A squared. So now we can cancel out similar things on the top and bottom, which is 2 concentrations of A. So what we're left with is just 1A. So if we're simplifying our rate law, I'm going to just pull these K constants over to be multiplied by all of the other K's, just to keep everything a little bit organized. So that's K minus 3 here, divided by K minus 1, K minus 4, and then K3. and that's equal to, so some of our A's are going to cancel out, so we're just left with a single A times B squared divided by C. So now we're getting even closer to canceling out the rest of our products. So we still have this one C remaining. So we're going to go back up to our rate laws again. We can cross off this third elementary step, and that leaves us with the second elementary step as the only one remaining. And it's convenient because it does have a concentration of C here. So that should let us substitute in for that final C in our rate law equation, and then hopefully we'll just get an equation that has the reagents in it. And then we can answer this question that's being proposed in question number 16, which is this a correct mechanism? Does the rate law that we calculate match the rate law from question 15? And if you'll remember, the rate law for question 15 was the rate is equal to some K times A to the 0 power times B. And since anything to the 0 power is just 1, this is the same thing as writing K times B. So that's sort of what we're hoping for. So we're going to take this second elementary step, the only equation left we have, and we're going to see if we can substitute in for C. So that final rate reaction was K2 times the concentration of A times the concentration of B, and that's equal to K minus 2 times C. And now since C is what we're trying to substitute in for, we're going to divide both sides by K minus 2 to isolate it. And that makes C equal to K2 over K minus 2 times concentration of A times the concentration of B. So now everything on this right side is going to be plugged in for C here. And remember, C is on the bottom of the fraction, so anything that we're substituting in is going to be flipped. Everything that's on the top goes to the bottom and vice versa. So I am just going to copy this. This is our rate law that we're substituting into. And then we're going to write everything out. And so we're substituting in for C. So I am actually just going to erase it, and then we're going to multiply by the reciprocal of whatever C is equal to. So everything on the bottom becomes the top, so that's K minus 2. And then it's going to be divided by everything that was on the top. So that's K2 times A times B. And so now we're going to do the same thing that we did before. We're going to cancel out anything that's similar on the top and the bottom. So we have an A and an A on the top and the bottom, and we also have some B's that we can cancel out. So there's 2 B's on the top here because B squared is B times B, and then there's 1 on the bottom. So one of these B's is going to cancel out from the top and 1 from the bottom. And so that gets rid of the squared, and we're just left with 1 B on the top. And then we can simplify this. I'm going to pull all of these K's over here, and what we're going to do is we're actually going to combine all of the K values into one sort of generic arbitrary K, because it's sort of accumulation of all of the rate constants of all of these steps. We're just going to call it K with no subscript, and that's going to indicate that it's equal to all of these rate constants in this reaction. So we have our rate is equal to some big K that encompasses all of those, and the only concentration we have left is just a single concentration of B. And then if we go back up to what we said was the answer to question 15 all the way up here, it actually matches what we know to be the correct rate law for this reaction, which is overall 6A plus 3b goes to 6c plus 2d. So this mechanism that we've been working with today is in fact a correct mechanism for this reaction. So that's kind of how we go through these types of problems. I know this one was particularly long and lengthy, and maybe a pain with all of the algebra, but hopefully this video helped you understand the different steps and the substitutions, so that going forward, hopefully the rest of your homework problems like this, exam problems and stuff, are a little bit more simple, because now we've sort of done probably one of the harder ones that you'll see. So definitely let me know if you have any other questions about this. Feel free to stop by office hours or send me an email, but hopefully this helps.